Good afternoon, everyone. I hope everyone's still wide awake. I know some of you have come far and might be kind of jet lagged. I'd like to welcome you this afternoon. We are going to enjoy a presentation about leveraging mobile test automation using Amazon Mobile Cloud AWS Device Farm. And presenting it today is Aniket Gadre. And take it away, Aniket. Thank you.
Thanks, Paul. Okay, hi everyone. Welcome to the last presentation of the day. Hope you are not tired. So, myself, Aniket, I'm senior SQA working in the identity team from Singapore office. Okay, so let me start this presentation with a somewhat contradictory statement that mobile is not a future. What I would say is mobile is the present. If you see the statistics which is displayed in this graph, so it's like in 7.2 billion population, already 4.9 billion unique subscribers are using mobile. And out of that, more than 60% of the people are using smartphones. That means they are using different type of apps, maybe Android, iOS, Firefox, whatever. So we have a huge amount of customers out there who are using our mobile applications. And if you consider Autodesk as a company, we have a lot of applications which are there, mobile-based applications. So it's very important for Autodesk as a company to focus on the mobile apps. The reason being, you must have seen, like, even if the smallest functionality can drop your ratings from like 4 rating to a 2 rating or 2.5 rating. And most of the people, when they want to install any app, they will just go to the rating and see if it's a 2.5 rating, they probably won't even install the app. So that's what it's necessary to maintain the quality of the mobile applications. And if I want to compare the mobile versus the desktop applications, so which is harder to test. So considering the features which are mentioned here, the first is feature functionality testing. So if we consider the same application which is developed for desktop as well as for the mobile app, we see that generally mobile app is like a subset of functionality which is there in the like subset of the functionality is present in the mobile app, while desktop has a more wide range of functionality. So in that case, if I want to test particular features of application, I might invest more time on the desktop app and I might have to spend lesser time on the mobile app, because mobile app will have like just the subset of functionality. So there is where like feature functionality testing, the desktop wins. It's easier to test than mobile. Going through the rest of the points, where test strategy, I think it's definitely harder in mobiles, because if you want to test a mobile app, you need to decide on various features like what operating systems your app supports, what versions of operating system your app supports, whether it's a very RAM consuming application where you need more processing power for the smartphone. So there are a lot of things needs to be taken care when you're developing a mobile application, while in desktop you have abundance of memory, you have abundance of RAM, so you don't really need to care about how your application is going to function on the desktop, because of huge RAMs available. Platform complexities, if you consider, like, we have 3 major platforms in desktop, maybe Linux, Mac, and Windows, but and they might have like 4 to 5 versions which are actively used by all the users all over the world. But if you see mainly Android and iOS, Android launched like around 13 versions till date since it was released. And iOS on a similar lines have launched a lot of versions as well. So the complexity comes where, let's say, Google deprecates some APIs which were there in the previous version and they are not there in the newest version. So your apps may start breaking because you are using older APIs. So these are the platform complexities which comes up in mobile application. Application deployment, that is where generally the deployment is very difficult for mobile, because let's say you are creating a native app and you caught a bug, and that bug is already there in the application, so user are going to face that bug. Now if you want the user to get rid of that bug, they actually need to install the new version of application, and that happens only when they will update their application. Till that, their application is still bug prone. But it's not the case with the desktop app, where you release the website or you release the desktop applications. You can also update the specific patches. You can release the patches and it gets uploaded and your desktop application is fixed. So that is another challenge with the mobile applications. Then the test automation. Test automation area is still new. I would say that not much of the R&D has been done in test automation regarding mobile apps, whereas for desktop apps, we have a lot of tools available for desktop application test automation. Performance test, again, it's not very easy to do on mobile applications because if you are checking on the memory usage, battery usage, CPU usage and all, it's not very easy to get those statistics on mobile application, but it's very easy to get it on desktop applications. Tools and support community, it's definitely growing for the mobile applications, but I would say it's still not have reached where we have the desktop applications support community. And the last is time to market. So mobile application mainly have a very smaller development cycles compared to desktop applications. So it becomes very easier. You can take your time to fix the issues with the desktop application, but mobile, if your rating goes down, like no one is going to install your app, and that's the main challenge. So out of this, all the challenges, we are going to focus today on the test automation. So what challenges do we see in the test automation? So first thing is the selection of automation tool itself. We have a lot of tools available in market. On the left hand side, you can see all the open source tools. On the right hand, you can see all the commercial tools where the license tools where you need to pay the license cost. If you see, it's very difficult to choose a tool because some tools are very specific to Android, some tools are very specific to iOS. Some tools may support both Android and iOS. Some tools may work with the instrumented code. That is, you need to have some libraries compiled with your application, and then that tool can take control of your application to do the automation. So it's not very easy to choose the tool, and again, they support different languages. So depending upon your developer's skill set or your tester skill set, you need to decide which tool you can go with. So choosing an automation tool is a challenge. Second is, as I said earlier, platform fragmentation, where you can see a lot of versions released by Android and iOS and its breakup. Of course, this is not a very latest because it doesn't display Marshmallow and Android, and it's still no one has started using it much. So, but you can see that if you want to test your applications, you need to take care of so many versions of the applications. You cannot say that my application doesn't support 4.2 because if you see, like still there are people out there who are using Jelly Bean, KitKat versions. Then the third challenge is selection of devices. So this is always a question on what devices should I test my application, because if you see Android, there are like hundreds of devices available in the market today, and iOS, although it's a one device, we have iPad mini, iOS phone, iPhones. So even though it's very easier for iPhone, for Android specifically, it's very difficult because there are different OEMs. The OEMs change the vanilla operating system a lot, and so they may implement new features, they may play with the operating system, they may change the UI. So there are a lot of things which goes into the Android phones when it comes to different OEMs. Then they, again, as I said, they have different processing powers, they have different battery consumption, they have different RAM consumption or the RAM power. So it's very difficult if I say that, let's say my application works smoothly on Nexus 5, I cannot guarantee that my application will work on Moto X. So it's a big challenge to decide on what devices you can test. Of course, you cannot test all devices, but you need to choose them carefully. So there can be a mixture of different OEMs, mixture of different operating versions, mixture of different RAMs, and then you can come up with a subset of devices which you can fairly say, if my application works on these devices, I can pretty much be sure that it will work on most of the devices. Then this is, I think, one of the biggest challenges, parallel execution on tests. So with whatever tools we saw earlier, you can just hook one of the mobile device into your USB port and your test may run. But what if you want, if I want my same code to run on, like say, 5 multiple devices or 6 multiple devices? So there is, if I start testing my device automation one by one, it's going to take me ages to actually complete my feature testing or whatever testing I want to do. So parallel execution is one of the biggest challenges we face in mobile automation. Last thing is continuous integration. If we see the development lifecycle of mobile, most of the continuous integration is done in simulators or emulators. The reason being, you cannot keep your devices hooked onto your machines to run the automation test. They can be in a locked state, they can switch off, their charge may go off. So you cannot really rely on the connected real devices, and that's the reason most of the development teams may prefer using simulators or emulators. The problem with simulators and emulators are they are very slow. If you consider, if anyone has used the Android emulators, which is provided by Google, it's damn slow. There are few options of using Genymotion, which provides a better simulators, but if you see like CI, there will be mainly 2 to 3 emulators which you will run your test on, and you can certify that my application is working fine. But when it goes to real devices, it may not even open, it may crash. So those are the challenges with the continuous integration. And when we write tests, we mainly focus on unit test, even for UI. We don't go into integration tests because integration takes a lot of time to run on single device. And if you have multiple devices, like because continuous integration is mainly about faster feedback. So if you are going to run your test on multiple devices and in a sequential way, it's going to take you a lot of time to certify your application. And the last one is platform-specific tools. So if we consider iPhone, for example, we need to install Xcode, we need to install XCT, we need to install many things, iPhone simulators, and it runs only on Mac. And if it comes to Android, we need to install JDK, Android SDK, and all that stuff. So it's not a very easy to have. If you are having an app for Android and iOS, even though app here looks very same, the setup which is needed for both these operating systems are totally different. So you're going to spend a lot of time in doing all these setups. So what is the solution for all these challenges? So this is where the AWS device farm comes into picture. This is the definition which the Amazon provides for AWS device farm. So it's basically a cloud service where you have multiple devices connected, and you can choose any of the device to run your test or do some manual testing. So we will see how it works. Okay, before that, we'll see why AWS device farm. So basically, it caters to all the challenges which I mentioned in the previous slides. So there is a huge pool of devices, right from the older devices to the newest ones. You can access any device anytime. And basically, you don't need to acquire the devices, because if you acquire devices today, in a month's time, those will be old when the new devices are launched, and then maybe you want to sell off the devices and buy new ones. So instead of that, it gives you flexibility. Today I want to run my test on this set of devices. Tomorrow I may want to run my test on different set of devices. So it gives you a lot of flexibility in choosing the devices. Geographically separated team can use the same devices. So let's say we have a team in Singapore, we have a team in US who is working on the same product. So if you want to run on the physical devices, we need to acquire devices in Singapore, we need to acquire devices in US office as well. So that is going to incur more cost. So instead of that, if you have the device available on the cloud, the whole team can be using the same device instead of using instead of acquiring the new devices every time. AWS device farm supports tests written with multiple automations tool. We will see how that works. It supports parallel execution on max of 5 devices. So your same test can run on 5 devices simultaneously, and it can give you results. So if let's say my test used to take 30 minutes, with 5 devices in parallel, it's just going to take me 6 minutes. So it's going to decrease the time a lot for the execution. Remote access to the devices for manual testing. Let's say I don't want to run automation test. I just want to pick up one random mobile and I want to test how my application works on that. So we can even do manual testing, but I'm not going into the details of how the manual testing can be done on the device. It generates variety of reports and videos for debugging. So it can generate screenshots of your test, it can generate videos which you can watch later how the execution happened on your device, and it can produce a lot of logs. So for Android, it can produce a logcat, which is a log of your application, how it was running, how much memory it consumed, and there is a lot of information which is available for that application. And the best thing is Amazon has exposed many device farm APIs which can help you to integrate it with the continuous integration. you don't really need to go to the UI of the console and run your test from there. You can just have a Jenkins plugin. You can run your test directly once your application is built and compiled. So that is a good part of it. And hence it's easily integrates with CI. So you don't really need to go to the console and run it. Okay, I will just give you a short overview of it. Automation tool called APM, because in the demo I will be showing how to run APM test on the AWS device farm. So it is an open source tool for mobile test automation, basically a client and server architecture where the server is developed in Node.js and the client libraries are whoever are like familiar with test automation tools must be knowing Selenium. So it uses the same Selenium client libraries and the server as the Node.js server. It supports the three most popular operating systems, Android, iOS. Firefox is not very popular, not many people are using it, but it's called Marionette and it supports the automation of the test on Firefox OS as well. It supports automation of all type of applications made with native, web or hybrid. You can automate each and every type of mobile automation on Android and iOS. The good thing is no instrumentation of app is needed. So whatever app you are testing goes into the production. Many automation tools require instrumentation of your apps where you will compile additional libraries with your application and then they can take control of your application. But APM doesn't need any instrumentation, so whatever code is going into production, the same code can be tested. And last but not the least, it supports multiple programming languages. So whatever your developers and testers are comfortable with, they can use Java, C#, Python, even JavaScript. So how can we use AWS device farm? So actually I had created the screenshots, but it's better if I can show you live how you can use it. Okay, so once you log into the Amazon console, you can see one option for the device farm. And once you land up here, you can just click and create a new project. You can give some name, so it will create a new project. Sorry? Oh, I think the desktop is not shared. It's not duplicating.
Did you want to get the?
Yeah, I want to duplicate. It's sung actually. It's sung. It's not responding. It's not duplicating the screen. Okay, I will try to control from here. Okay, so this is where you can create a project. You can just give a name. It's just for the segregation of your test. And once you give it, so your project will appear here somewhere. And if you click on this project, you can create a new run. So when you create a new run, it will ask you like whether you are automating or you're running test on your native app or you're running test for the web app. So let's say I select a web app here. and then you can just give any name for your run just to differentiate it between from the other runs. Then it will ask you like what type of test you want to run. So as I said, AWS Device Farm for Android, it supports APM. So the test can be written in Java, test can be written in Python. So basically I have a sample test which is written in TestNG. I have written a test in Java. So I can just upload the test. So this test is basically a zip file with all the dependencies for your project. So you might be using different jar files as a part of dependencies on your test automation project. So everything which needs to be as a part of dependency needs to be inside the zip file. And once I do it, it's just uploading my test to the cloud. Then I can do next. And then here it asks me to choose the devices on which I want to do my execution. So either I can create a device pool because I know that I will always be running my test on these 5 to 6 devices. Either I can create a device pool, or I can say just top devices. So top devices, if you see, it's like a mixture of iOS, Android, and different OEMs and different operating systems. So instead, or if you want to create a device pool, you can go here. You can just filter, like let's say I want to run on all Nexus devices. And it will list out all the Nexus devices, and let's say I want to run on just the Marshmallow. So I have all these devices available. I can just choose the devices, and I can give some name, and I can save. So this is how you can create a pool. And once you create a pool, so here I have one already created pool. I can just click next. So it's asking to review the run. So I have selected my application as web application. I have selected my test as APM TestNG test, and I have selected my device pool. And once I do it, I can just confirm and start on, and now it's executing my test on the cloud. So it's going to take some time, so I will just show you a few of the results from the previous runs. So this is the run which I did a few days back, and showing like few of the tests have passed and few of the tests have failed. So I ran on HTC One, Huawei Nexus 6, and Samsung Galaxy. So if you click on any one of the results which you want to see, so it's going to tell you the tests which are run. So like I just had a setup at teardown for the test, and this is my main test. And there is a lot of log which is being displayed when it runs on the cloud. So let's see like what has failed here. So if you click on it, it's going to show you each and every test which was executed as the part of that suite. So let's say I'm going to click on the first test, which is failed. So I want to see like what is the reason for failure. And these are the logs which are being printed from the assertion or from the failed step, saying so you don't really need to go into the detail. You can see all the logs, execution logs for that particular test which are being displayed here. And let's say if I want to see the screenshots. So I was just automating a login scenario of our Oxygen application, and you can see like it depends like where at what point of time you are taking the screenshot. So you should have the test code present in your test to take the screenshot. So I'm seeing that I have taken the screenshot of these 3 steps, and so if you see below. The reason my test failed was I was expecting a user profile screen once I logged in, but instead of that, because the user had enabled the 2FA screen, I got the 2FA screen instead of the profile screen. And from here I can make out that okay, my test failed because the profile screen didn't appear. So instead of that, the 2-factor authentication screen appeared.
Hey, 1, 2. They had it in the White Mountains.
And these are the files which we can see. So there is a Appium Java output.
Hey,
This
one, two.
output is
1, 2, 1, 2. 1, 2. Hey, 1, 2. 1, 2. Hey, 1, 2. Hey, 1, 2. Check. 1, 2. 1, 2, 3, 4. Hey. Check 1, 2, 2. So I swapped out just when he's moving, all that.
okay. Yeah. Thanks. Okay. So here you can see the logs which were generated by my test, all the Java logs. You can download any log from here. And you can even see the server logs which Appium is producing, and even the Logcat. So these Logcat logs are directly coming from the Android device. They are being stored here on the cloud. So anytime you want to revisit the logs, you can go and see what were the issues with the application. And then you can download the video as well. So I will just show you one of the sample videos. So this is actually the execution is happening on the device on the cloud. The only limitation I see with this is when it's actually executing, I cannot see what's happening on the device. Only when the execution is complete, I can go to the videos, I can download the videos, and I can see like what's happening on the device. So this is for the pass test where the 2FA screen didn't appear, and the test could navigate to the profile screen. Okay, going back to the presentation.
So that was on a physical device?
Yes. Okay, so coming back to the presentation, the limitations which I could say is the limited control over execution of test. So if you see, I just uploaded a zip file, and whatever tests were there in that zip, all tests were executed. So I cannot have a control over, I want to run just these 4 tests on my device. So I need to create a different zip file with a different build. I need to upload it again, and I need to run it again. So of course, this is like a maturing platform. A lot of things are changing. When I started doing this presentation, the video capability was not there. So it was introduced lately where we can download the videos and you can actually see what's happening on the device. So this platform is still maturing. There are a lot of functionalities which is being added currently. It's like very new right now. I think there are many people who had raised this concern in the FAQs that we cannot run a specific set of tests. We need to run everything which is there in the zip file. So the response was they are coming with some approach where you can just pass the flag, like I want to run just the smoke test or the acceptance test, and it will just run those tests. Actually, Appium as a tool supports many languages. It supports C# as well, JavaScript as well. But currently, Amazon Cloud only supports the test written in Java and Python. Maybe in future, they will support the test written in C# as well. And no live view of execution. So whatever you can see is after the video is generated, you cannot see the execution happening at the runtime. So this is just a small comparison with the competitors of Amazon Device Farm. So Sauce Labs is one of the very popular cloud service provider for mobile apps testing. Till recent times, they were not having capability to run the test on the real physical devices. but with Amazon and Google bringing the execution capabilities on real devices. So Sauce Lab also has now that capability. Only thing is the device pool is very limited. You have like only 10 to 15 devices which you can choose from to run your application. But if you see Amazon, if you had seen the list in the previous demo, there is a huge list of devices which is available for execution. Google doesn't have any support for iOS. Currently, they are supporting only Android, and they are supporting only the instrumented test. So you can either use Espresso or RoboTM or something where the code can run directly from the Android Studio. So actually, you cannot run it on fly on just uploading your test to cloud. It needs to be integrated with Android Studio, and from there you can run your test. Parallel execution, everyone supports it. Amazon currently supports it only for the 5 devices. Maybe going forward, they can support it for like 10 to 15 devices. Tool support, as I said, this is mainly automation tool support. Tool support not in terms of only the compatibility of the tool, but what tools are being used, how big is the open source community for that tool, whether you can get any help if you are stuck with those tools. So whatever tools Amazon is supporting, they are like widely used tools for mobile automation. And whatever the Google and of course Sauce Labs is the one which created the APM tool. So they by default support that. And the CI integration, like everyone supports it some or the other way. So Sauce Labs, even Sauce Lab has the APIs which are exposed. So you don't really need to log into Sauce Lab console and run from there. You can just call their APIs. You can select the device pool. You can just trigger the test from your CI. Yeah, so I think that's it from my side. If anyone wants to download the demo which I uploaded and I executed, you can just visit the GitHub URL. You can download the demo from there. And if you want to get in touch with me, you can use LinkedIn.
We have about 10 minutes for questions. Does anyone have a question?
So I was wondering how they create a video of it. Like you mentioned that they don't show the live review, right? So is it like they take a picture, sequential pictures, and mash together to create?
I'm not very sure about that, but on Android nowadays you have the feature itself that you can do the video recording of whatever is happening on the device. iOS, I haven't tried it, so I'm not very sure whether the video capability is even available for iOS. But Android, yeah, I think there are many tools which can help you capture the video. Okay. But I'm not really sure how Amazon is trying to do it.
Yeah.
Hey, what kind of feedback do you get whenever devices crash on you?
I'm not sure whether I can show you one. So in one of the thing was the network connectivity was not there, and it was just showing that dinosaur screen of Chrome where it says no network connectivity. So these things, if you have got a screenshot, because my test failed there because the expected page was not there, I was able to find from the screenshot itself that there was no network connectivity. Or in this case, you can go to video and see. But if you are not able to make out from the video and screenshot as well, there is always Logcat, which can give you a detailed analysis of at what time your application started, what functionality application was doing, whether it crashed or not. So it can give you many things from the Logcat logs.
Hi, when you were showing the example, you said this will take a while. So I'm curious, in a continuous integration environment, what's the turnaround time from submitting the job to receiving the results? Excluding the execution time of the test itself?
So it actually depends upon how many tests you are executing, because if you see, generally the execution on mobile devices are slow compared to the desktop applications. So I think we need to come up with an appropriate set of tests which we really want to run as a part of continuous integration, because it can take really long to actually do the execution. But I would say like at least 20 to 30 minutes max, what you can expect here. And if you are running it parallelly, yes, because the same tests are running on multiple devices, you don't really need to wait for all the devices to complete. So as and when the device is completing the execution, it starts showing up. Okay, one more thing I wanted to tell you is how does the billing happen, because this is of course a paid service, it's not definitely free. So this is the total time in minutes which is being shown for each device. If you click further, you can get the time for each test and so on. And if you see, there are two timings. The one is the total timing and one is the meter timing. So meter timing is the one where your device is actually in use, or the test is actually running on the devices. So your test might be doing a lot of things where the actual step is not being executed on the device, and you might be doing some setup, you might be doing some tear down for your test, you might be creating some data for your test. So Amazon is going to charge you only for the metered minutes, they're not going to charge you for the total execution time.
So in your demo, you showed an example of how to do a web app. So how, from just a practical standpoint, how would you do an iOS app? Would you actually send the iOS IPA up to the server? And obviously Amazon has solved the fact that Apple is very restrictive with installing apps on their devices.
Yes, correct. So one good thing is, as I said, APM. If you are using APM as a tool, you don't need to alter the IPA file. So if you are using any tool which requires instrumentation, you actually need to compile it with different libraries. But if it's an IPA file, you can just like APK can be uploaded, you can upload the IPA file. You will need a developer certificate for that, because without that, even Amazon cannot install the device, the application on the real device. So they will just create a temporary developer certificate, and with that developer certificate, they are going to resign your application. So they are going to extract the content, they are going to resign your application with the developer certificate they have, they are going to rebuild the IPA file, but yeah, it's not altering any code, it's just altering the certificate. Yeah. So, and once that is done, then your app is ready for automation, so you can execute the tests.
Basically, they have to resign the app.
Yes.
Okay, wait, question over here.
Thanks. So do you know when you have a Selenium grid, you have a hub and you can use the URL and send tests to that URL? Do they have a similar setup?
Not very sure about that, but generally whatever my experience goes with the device clouds is they have a huge room full of servers, and each server has like multiple USB ports configured for different ports, and there are like lot of devices attached to that servers. So when I'm firing a command, I'm targeting a specific port. So any command going to that port is going to go to that device. So that's how they work. So I don't think they have implemented any Selenium grid for parallel execution.
Okay, I see. Thank you.
I think we have time for one more question, if anyone. Oh. I feel like Phil Donahue.
I had a question if you'd like to test a device with a non-English UI, like a French language or Japanese. Can you request a device in a particular language, or is that the first step in your test app is to kind of change the language, an API to change the language?
So I don't think you can change it from the Amazon console, but the automation tool which we are using supports it. So you can set a language before you start your execution. And if you want to do a testing on multiple languages, so it's like you can put it in the setup method, whichever language you want to run against, and it will set that language on the device.
Okay, perfect, thank you.
I guess especially if this is the last session, if there's one more question, I would take it. Anyone, anything else to ask or add?
Yeah, hi. So I have automation written for the desktop. So like in Selenium Java and using TestNG framework. So what would be my first step if I want to integrate into this APM?
With Amazon?
Uh-huh.
Okay. So yeah, you still need to do a lot of setup because before you start running your test on Amazon, you of course want to test it locally first, whether your tests are actually running on the device. So if you want to start with APM, which I have used here, for Android you just need an Android SDK and JDK. And so Android SDK comes with a lot of tools which are used. So one tool is like a UI Automator Viewer, where you can go and you can spy the properties of different UI objects on the Android application. And you can, similar the way if you go to the web app, you can go to the Chrome Developer Tools and you can fetch the properties and use it in your automation. Similarly, Android UI Viewer will give you also a set of properties. So you can use exactly the same way you use Selenium. There is no difference. Only thing is an initial setup is needed, where Selenium you can just start running your test, right? But and if you are using iOS, there is a much bigger setup which is needed. So you need Xcode, you need many tools which supports iOS development. You need a Mac basically. You cannot run on Windows machine or Linux machine. So yeah.
Thank you.
Okay, well, I believe we're out of time now. I want to say thank you for your patience with the technical issues, and thanks for coming, and thank you, Aniket, for a fantastic presentation.